All right. So in Module 1A, our primary goal is to observe the moon at optical wavelengths. We're going to want to image the entire moon, and we're going to want to do so in color. And we're going to use the subtle color that we see in our image to do a little bit of prospecting, some lunar mineralogy. But let's back up a little bit and start by talking about what features we see on the moon. And in general, there are two classes of things you see on the moon, and those are craters, which it's apparent what they are in this picture, and then you have these dark splotches, and those are called the maria. Let's start with the craters. So the craters, pretty simple, caused by impacts. The maria are as well. Let's start with the craters. So space is full of all sorts of debris, small rocks, and the small ones we call meteoroids when they're in space. If they're passing through an atmosphere, like if they enter Earth's atmosphere, we call them a meteor. And if they hit the ground, if anything's left, we call it a meteorite. Now, Earth's atmosphere is great. It protects us. A lot of these small things burn up in our atmosphere. Only the big ones make it through and become meteorites. Now, on the moon, there is no atmosphere. So you go directly from meteoroid to meteorite. So here you see a meteoroid coming in, strikes the surface with a tremendous amount of kinetic energy. It's converted into heat, melting the rock. It sends shock waves down beneath that can actually kick up some geological activity over the years to come. But it melts on the surface, throws the stuff up. I was going to say up in the air, but there is no air, just up off the surface. Excuse me. And then it comes down. And some of it is thrown away from the crater. We call that ejecta or an ejecta blanket. But a lot of it ends up right back in the crater. You can see here. So the craters aren't very deep because most of the stuff ends back up in there and melts, making a flat surface. Here's a picture of the surface of the moon. One of the biggest, most famous craters is Copernicus. You can see it there. If you look at it from the side, and we can because we've been to the moon, we've orbited the moon and taken pictures, you can see how incredibly shallow the Copernicus crater is. Now, when you have that impact and the material's being thrown out, the ejecta, it's hot, it's molten, and some of it will bead up before it lands back on the surface. And see, here are some of these beads that have been picked up by the astronauts and brought back to Earth for study. And interestingly, if you look at this one under a microscope, you see it also has an impact. And so meteoroids come in all sizes, from very big down to tiny, tiny sizes. And we call these micrometeorites, and they're striking the moon all the time. There's actually erosion on the moon. You don't think about it. With no atmosphere, no weather, why would there be erosion? Well, the erosion's caused by the micrometeorites. Slowly, they wear away the craters and new ones come. So the surface does change slowly with time. Now, this is an example of one of the smallest impacts. The biggest impacts are what are responsible for the maria. Now, these formed about 3 billion years ago. There's still a lot of big stuff floating around the solar system. The first 500 million years was really, really busy, and then it started to taper down as things were thrown into the sun or ejected out or impacted the planets. And when it impacted the moon, particularly on the Earth-facing side, the crust is a lot thinner on the Earth-facing side. Those that hit the Earth-facing side, if it was big enough, it could crack all the way through the crust down to the lithosphere and melt it. And it would then burble out onto the surface. And so we can see these regions here. Now, this is a color-stretched picture of the moon. We'll learn how to do this. The moon is not just black and white. There are subtle colors, and you can play with the color saturation and bring them out. So if we look in the maria, we tend to see two colors. Some are blue, like the Sea of Tranquility here, very blue. And that's due to titanium mixed in with the rocks. Also, you see browns like here and here. And these are lava flows. Back when it was molten, you'd have lava flows until it cooled down and resolidified. And they have a lot of iron, and so kind of reddish, brownish hues. Now, you also get the impact craters, beads of different colors. So when you have the impact and threw the material up, some of it beads up, like I said, and some of that is blue, again, due to titanium. And you can see that here. This is called wood spot, or uh, yeah, this is wood spot. It's right next to the Aristarchus Plateau. I'll mention both. Wood spot, you see a lot of blue. This is kind of glassy beads with a lot of titanium in it. And then next to it, and often these craters, you'll see yellow because the impact was so great, it kind of reactivated the geological activity in that area for a short period of time. And that produces yellow and black glassy deposits, such as these that the Apollo astronauts brought back. And you can see that tinge here. And you can see it in other places if you make a really good image. Now, there are different times that you can observe the moon. The phases are always changing. Again, here's the basics. You learned this in elementary school and middle school and high school. So you've been taught the phases over and over. We have Earth. Let's say the sun is over here. The moon is going around the Earth. So as viewed from the Earth, different fractions get illuminated at different times. And when you're doing mineralogy, you're going to want to observe around the full moon because then you see everything. In this case, the sun's on this side, the moon's behind us, but not completely behind, not in our shadow. That would be an eclipse, but sort of behind us. So it gets fully illuminated by the sun. You can see the whole thing. And that's good. The thing is, when the moon is in that position, you don't really have three-dimensional craters. If you really want to see craters, look at a different phase. For example, first quarter phase here. In this case, the sunlight's coming in from the side. So these moons here, these craters on the edge of the moon are being illuminated from the side, and they cast shadows. It's those shadows, that makes them look so three-dimensional. Where you can see here, this stuff that's being illuminated directly looks rather flat. So I encourage you to make your moon picture twice, one around full moon and one at some other phase other than new moon. One for mineralogy and one to check out the craters. Okay, I'm going to stop there.